Hello, hello, and welcome back to Chapter 10, Probability. Today we're going to be focusing on Lesson 7, Combinations. Now, throughout this chapter already, we've looked at a lot of different ways to find probability. We've used probability to find marbles. We've used probability to find the probability of flipping a heads or a tails on a coin. We found probability of, rolling a cube or finding the probability of flipping a coin and rolling a cube, right? We found even probabilities with a spinner or a spinner and a cube or a spinner and a coin, flipping a coin. And we've also dealt with probabilities dealing with a whole bunch of money, right? Now, there's a lot of different types of diversity when we're dealing with probability, and one of those things, which is kind of like the next step further, are talking about combinations. Now, combinations, that is a selection of objects in which the order is not important, okay? The order is not important. That's really, really, really key. Combinations, the order is not important. Okay, combinations, the order is not important. And as we get into some problems, you're going to see what I'm talking about. Well, we have to remember that. I know combination, that's probably a new term to you, but we need to remember it's a selection of objects in which the order is not important. And one way to determine the combination, it's really, really key whenever you're dealing with probability. And where it comes in to probability is when you're dealing with the favorable versus the total number of outcomes. Okay, so the combination is really going to be here in the total number of outcomes, determining what number goes on the bottom of that fraction in dealing with probability. That is the point of learning about combinations, because there's such a diversity. Everything isn't about marbles or cubes or spinners, right? There's a lot more other things that people use to find probability. So let's talk about an example. It says the school district is going to plant 2 types of trees around the playground. Okay, so the school district is planting 2 types of trees around the playground. The landscaper, okay, so we have 2 types of trees. So they're only planting 2 types. And they have, the landscaper has 5 kinds of trees to choose from. Okay, so what the problem says is let the letters A, B, C, D, and E represent the different kinds of trees. So there's 5 different kinds, so here's your different kinds. 1, 2, 3, 4, 5. You can make an organized list of all the possible combinations. So let's say we want to write all the different options. So let's say we want tree A to be one of the trees. Well, tree A can go with B, tree A can go with C, tree A can go with D, or tree A can go with E. Okay, so those are all of the combinations of planting tree A with another type of tree. How about if we plant tree B? Okay, what are all the combinations that if we know we're going to plant tree B, what else it could go with? Well, tree B could go with A, tree B could go with C, tree B could go with D, and tree B could go with E. So those are all the combinations if you know you're going to plant tree B. Well, what are all the combinations if you know you're going to plant tree C? Well, tree C can go with A, tree C can go with B, tree C can go with D, tree C can go with E. Those are all the combinations for tree C if you know you're going to plant tree C. What about if you know you're going to plant tree D? Okay, so tree D can go with A, tree D can go with B, tree D can go with C, tree D can go with E. Those are all the combinations if you're going to plant tree D. Lastly, how about tree E? If you know you're going to plant tree E, what are all the combinations of other trees that can go with tree E? Well, tree E can go with A, tree E can go with B, tree E can go with C, and tree E can go with D. Okay? So, and those are all the combinations of tree E. So now we have all of the combinations for each separate tree on its own, which means we have all of the combinations of all of the options for, or outcomes for the 2 trees. So, how many groups of 2 trees are in the list? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We can count it individually, or we could use our multiplication. There's 1, 2, 3, 4 in each row. 1, 2, 3, 4, 5. 4 times 5 is 20. Okay, so there's 20 in the list. But something that is a little interesting about this problem is that AB, if we're looking at AB right here, what is the same combination as AB? So if you're going to plant 2 trees, if you plant AB or if you plant BA, those are the same thing, right? AB represents 2 types of trees, and BA represents those same 2 type of trees. So really, AB is the same as BA. So these would be considered duplicates. This one is not needed because it's only a duplicate of AB. Okay? Let's look at AC. AC. Well, what is the same as AC? Well, the same thing as AC would be CA. So these are the same thing. So we don't need to list it twice because the order does not matter. In this example, whether you plant tree A with tree C, or you plant tree C with tree A, they represent the same thing. So this would be a duplicate answer. So that's what the order of the letters, when we said combination is a selection of objects in which the order is not important. That means if we have AB or BA, they equal the same thing. Okay, because the order of the letters is not important. This is one thing. That represents one outcome, or one outcome would be a more mathematical way of saying that. And I could write it better. I'm gonna use my really nice handwriting here. Outcome. So that represents one outcome, A, B, and B, A. Okay? Okay, so let's move back down here. Okay, so AC is the same thing as CA. That represents one outcome. So we can get rid of the CA because it's represented here in AC. How about AD? AD, the combination AD, is the same thing as DA. Those represent the same thing. So I'm going to cancel that out, DA. And AE, AE is the same thing as EA. I'm going to cancel those ones out. And then we're going to move on to BC. Well, BC is the same combination as CB. Those are the same outcome. So we don't need both, we just need one. Because the order is not important, whether it's BC or CB. The order of the letters is not important. It represents the same thing. Okay, BD here is the same combination as DB. So as DB, so we can cancel that one out. BE is the same combination as EB. So we can cancel out EB. And then CD is the same combination as DC. So we can cancel out that duplicate. And then CE is the same combination as EC. So we can cancel out that duplicate. And finally, DE is the same as ED, because the order of the letters does not matter. So we're going to cancel that one out as well. So these are actually the true outcomes for this problem. These are the possible outcomes right here. And so how many are listed? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 outcomes, 10 left. Okay, so if we were trying to find the probability, 10 would be the number that we put on the bottom of this fraction if we're trying to find the probability something. So if we want to find, hey, what's the probability that tree A will be planted? So if we want to find what's the probability that tree A will be planted, then we would have the favorable over the total, and the favorable that had tree A would be 1, 2, 3, 4, and the total would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So before tenths, you'd reduce that. 2 goes into 4 2 times, 2 goes into 10 5 times. So the probability that tree A would be planted would be 2/5. That's how it gets into the bigger picture. That's why, because there's just different types of examples when it comes to probability. And so this is kind of like a more kind of advanced topic than just talking about cubes or flipping coins or Minecraft marbles, even though I really, really like them and they make me smile when I see them. So, yeah. Okay, perfect. So those are combinations. Let's go ahead and talk about the next example. Okay. Make an organized list of all the possible 2-letter combinations using the letters U, V, W, X, Y, and Z, and cross out each duplication. So make an organized list of all the possible 2-letter combinations using the letters U, V, W, X, Y, and Z. Okay, we can do that. All right, so let's start with UV. So I'm going to start with U. You can go with V, which is listed there. You can also go with W. And I just like to do this in kind of like a systematic way. So I'm going to go UV, UW, UX, UY, UZ. Okay, so we have UV listed there. The next one is UW, and then following would be UX, and then UY, and then UZ. So those are all the combinations involving U. Now let's jump to V. Well, the first one would be VU, right, which is listed there. And then we'll move here, VW, and then VX, and then VY, and then VZ. So those are all the combinations involving a V. Now let's go to W. So W is going to be, first one's WU, so that's listed there, then WV, and then WX, and then WY, and then WZ. Okay, so those are all the combinations for W. And now we're going to move on to X. So XU is the first one, and then XV, and then XW, and then XY, and then XZ. And then we are going to move on to Y, right? Because Y is the next one. YU, and then YV. Oh, we already have YU here. This is YU, sorry. So YV goes here because YU is already there. YV, and then YW, and then YX, and then YZ. And then the last one is Z. So we're going to start with ZU, which is listed, ZV, ZW, ZX, ZY. And I think it's kind of cool in this column here, everything has a U. In this column, everything has a V. Oh, this is supposed to be V. I messed up on that. That's supposed to be V. Sorry about that. That's supposed to be V, W. Oh, man. So everything has a V there. Everything here. Oh, no, no, no. It's supposed to be U. This is supposed to be U. Never mind. Just forget what I said. This is supposed to be U because this is all U. This is all U. just never mind. Just forget everything I just said right there. Okay. So, we have all of the outcomes listed, and right now there's a total of 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6. So that's 5 by 6 would be 30 outcomes. But there's a lot of duplicates in there. This U is right. I did this correct. I hope I didn't confuse anybody. If I did, I'm sorry. Okay, so we're going to go ahead and cross out each duplication. So we're going to start here with UV, and UV has a duplication of VU, so we don't need VU. Now let's move on to UW. UW is the same thing as WU, so we're going to cancel that one out. UX is the same thing as XU. UY is the same thing as YU. UZ is the same thing as ZU. Okay? And it kind of works out when you just go in this order and then you just want to keep working your way down. So the next one we're going to start is VW is the same thing as WV. VX is the same thing as XV. VY is the same thing as YV. And VZ is the same thing as ZV. Okay, then we're going to go here. WX is the same thing as XW. WY is the same thing as YW. WZ is the same thing as ZW. And then we're right here. XY is the same thing as YX. And XZ is the same thing as ZX. And then YZ is the same thing as ZY. So there we have it. We have all of our outcomes are right in this general region here. Okay, and it kind of forms a little triangle there. So we're going to count up the number of combinations of 6 letters taken 2 at a time. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 combinations of 6 letters taken 2 at a time. All right, we will see you next time. Goodbye.